Class, I would like to tell you a story. It's a story about how computer networks, in a sense, evolved, particularly in the United States, and where we may be going in terms of how organizations store data and use computer applications. Now, that may not be your idea of an ideal story, but I think it's an important story, and I think that given your aspirations to continue to be or to become managers of departments or organizations that depend upon computers, that you would do well to understand the essence of this story. Modern computers began to be used by organizations in about the 1960s. And the very early computers were large mainframe computers. I have never seen a mainframe. I've seen a building in which they said there was a mainframe inside, but I take their word that mainframe computers were, and in some places still are, very large computers, as large as perhaps an entire room, that were heavy, expensive, troublesome, and rather limited in what they could do for the organization. It was as if an entire organization was running on and depending upon one computer with the approximate capacity of a modern Macintosh desktop or tower. And that's the way it was in the 60s and 70s. Companies like IBM and Burroughs and others sold these machines for $1 million or so. And they sold companies on the idea that you're a big company, you need a big computer. And everybody depended upon that one big computer. And in order to get information or data from the computer, the employees depended upon specialists who had the ability to interface with that computer. And then a small step forward was the invention of punch cards called IBM cards. And people began to program, to write their requests as holes punched in cards. And those cards were run in batch at night, and one day you would deliver your stack of cards, the next day you'd come back, and if you were lucky you had the printout on green bar, but more likely you got a message on 1 or 2 sheets of green bar paper saying there was a mistake on card 3, please try again. Okay, at some point people connected what were called dumb terminals to the mainframe computer. A dumb terminal was a primitive screen and a keyboard, but it was a big step forward because at least now there was the possibility of some real-time interaction with the computer as opposed to batch processing. But still, the entire company, corporation, whatever, was running on one big computer. Then in about the 1980s, people began to build and to distribute what we know today as microcomputers. Desktops, laptops, that sort of thing. Of course, they weren't laptops back then, but microcomputers. And this was a toy, sometimes sold as a kit that you could take home and build. And people began to realize that these toys had potential value. They were small computers by any standard, especially by today's standards. But when somebody, for example, invented a spreadsheet called Lotus 123, or maybe it was Quattro 123, that would run on these and would save accountants having to do all that erasure every time one of the numbers changed. People began to realize that these small machines had business potential. Then somebody had the bright idea of swapping out the dumb terminal wired to the mainframe with one of these new microcomputers and making it look to the mainframe computer as if it was still interacting with a dumb terminal. And I think, in my mind, this is the beginning of client-server computing. Because now you had essentially two computers and two processors responding to the needs of the human user, not just one. And this began to open up a whole lot of possibilities that did not exist prior. This is called client-server computing. And client-server computing is very important, very good. Every computer has hardware, an operating system, and applications that run on the operating system. So every computer, whether it is networked or whether it stands by itself has a three-layer architecture: hardware, operating system, application software. The application software, like Word or Excel or whatever, is designed to talk to the operating system, which is a layer of specialized software. And then the operating system talks to the hardware. And this is a good way of doing things because it makes it a whole lot easier to write applications, because the person who writes the application doesn't have to think about the hardware. All he or she has to think about is the operating system. So if you could write the application to talk to the operating system, and the operating system has been written to talk to the hardware, you've divided the challenge of complexity into these layers, and you've made it easier to address the enormous complexity of writing software and making hardware do what you want it to do. Okay, so we've got machines with this layered architecture now in a client-server configuration. And in client-server, you have what are called tiers. Usually the presentation tier, the business logic tier, where the application actually runs, and then you have another machine in the background on the third tier called a database. 3 layers, 3 or more tiers, and enormous potentials to begin to leverage the benefit not only of multiple processors functioning at the same time in some kind of a coordinated way for a purpose, but also multiple human users on the network at the same time in order to support some business process. This is design, this is engineering, and it's exciting to realize that the challenge of organization, or one of the challenges of organization, is to design the organization so that the humans and the machines are pulling together, and the machines are working with other machines in productive ways, allowing the humans to work with other humans in productive ways. Okay, so we've gone from highly centralized mainframe computers to these decentralized networks in which people now work. One of the problems with I need to end this and start another tape because of the limits of YouTube. I'll be back.